Alright, kelas okay, hari ni tak apa. Next class just be saya have to remind are you listening class Next class I think semua kena on the camera Boleh? Today tak apa. Next class just take note Next class for the next class on the camera. I need to see your face. Okay? Alright, okay. Is anyone recording? Abdullah, are you recording or not? Alright, okay, thank you Abdullah. Okay, today we already learn about last week we learn about VBAP selection. You did know that we have assignment your VBAP in your e-learning. Make sure you do that assignment. Okay, we already learned about bearings. Okay, previously we learned about gears, right? Gears where we learn about gear dynamics and also gear forces. From the power input, then we calculate the torque. From the torque, we know the F tangent gears. So from the F tangent gears, then we can calculate all the reaction of forces on the gear tooth of a set of gears. Like gear 3 to gear 2, we know F tangent 3-2, F radius 3-2, and so on. We rather than for gears, we only until we know the gear dynamics. We learn about gear trains, the speed ratio, where is your train value, and last equal to E and first, and we learn about gear forces. Okay, today we continue on gears part 2, gears part 2, where we have not covered yet about the gear tooth strength. The strength of your gear tooth, because gear tooth you need to calculate either the gear tooth will it sustain based on the load applied on the gear. Remember, on gear forces we do calculate the F tangent and F radius on the gear tooth on each gear. So these forces that acting on this gear, especially we can disregard, we can ignore the F radius. I'm talking about F tangent on the tooth of the gears. Because gears, based on gears, we need to calculate, because before this we only learn about dynamics. We only learn about dynamics. If you look my live video, boleh can you see my live video? Okay, sharp. Is it okay? Sharp, class? Video okay tak? Okay, before this we learn about gears. We calculate because we have small gear, we have big gears, we have pinion and gears. So we have let's say the gears counterclockwise direction. Okay, so this one will be clockwise direction. We have also this gear 2 N2. This is your gear 3. Number of things is N3. Before this, we know how to calculate speed, right? We know how to, for gear 2, you can calculate, gear 2, you make forces of D. If D is drive, D is driving, so this one will be driven. So impact from gear 3 to gear 2 is like this. You have F tangent 3, 2. You have, this is from left to right. This one is F radius 3, 2. So we only calculate force. Before this, we only learned how to calculate speed ratio, and how to calculate force. Okay, how to calculate force, F tangent. We know how to find. Oh, this one we have here. Of course, we have AX here, and this one we have AY, reaction from the shaft, and also this one produced clockwise. So this one will be counterclockwise. So this one will be counterclockwise top at A. So this already we learned. We know how to do this. But if you look carefully, focus on, let's say, on gear 2 itself. On gear 2 itself, if you focus the gear tooth itself, this is, if we zoom it, this is the tooth of your gear 2 at the bottom. I just draw only one tooth only. So, this is gear 2, right? This is gear 2. Free body diagram. Gear 2 is at the bottom. If you look carefully on gear 2, so it means this is the tooth. If we zoom in the tooth of your gear 2, so we have F tangent here, right? Acting on the surface, because the gear 2 is rotating like this, counterclockwise. So it will be impact from, because it's a driving. So impact from gear 3. So this one we have F tangent 3, 2. And we also have F radius 3, 2. Actually, the second part of your gear analysis, you need to calculate, will this tooth sustain or not? Will this tooth survive or not? Can it sustain the load? If you look carefully, the radial load actually does not cause any effect, does not harm the gear tooth. The one that harm the gear tooth is this F tangent is critical, because this F tangent will produce bending stress, because here we have bottom here, we have the dedendum here. So this F tangent will cause bending stress. It will cause will affect the strength of your gear tooth. So will this gear tooth survive or not with this F tangent? This one we can ignore. Actually, there will be some axial force on the gear tooth, because gear tooth, let's say you assume gear tooth is one cantilever beam. You assume it's one cantilever beam like this, cantilever beam. And the cross section is square. It's a rectangle, right? The cross section. Consider then you have F tangent. You have F tangent like this. F tangent on the cantilever. And this one is a fillet, right? So it will cause, if you have F tangent, so this is your cantilever beam, so it will cause bending stress here. There will be stress here at this neck. Okay, if this is the neutral axis, this one will sustain apa? This one will sustain tension, right? This one will sustain compressive stress. The value is the same, but this one in on tension, this one in, because we F tangent is like that. This will produce tension, this one will go for compression. So the sigma bending we have to calculate. Caused by the F tangent. No, we can ignore the F. Actually, we have F radius gears, right? F radius. We have F radius pointing to the center of your gear, but we can ignore it because it actually harmless lah. Small. It will not harm the tooth. The one that critical that will harm the tooth, the strength is your F tangent. F tangent. The impact from the, actually, remember gear we have total force, right? This right is actually on the phi is your pressure angle lah. Pressure angle of your gear is 20 degrees, right? 20 or 25. So actually we go for F tangent. We already know how to calculate. Previously we know. You remember how you calculate from the power, you got your torque. From the power, you got your F tangent, right? F tangent time velocity is the power. So you got your F tangent, then you calculate all F tangent, all gears you can transmit, all you can know. You can find all the force, reaction, F tangent, and F radius on all gears. Okay, for example, okay, now we focus on gear 2. So we must, okay, our second analysis on gears, we does not end there, only on force analysis. So we have, if we have force, we have stress. We have stress. So we have stress, so mean, okay, mainly, okay, actually in gears, okay, we have gear part 2 already, we have two sections. We have to, first is for bending stress. Okay, for today's lecture. On the second lecture, we'll go on surface stress. Surface stress, later on, I will explain you on the second lecture. But today, we focus on the bending stress acting on the gear. So the bending stress that caused on the gear tooth is your F tangent. So assume like this cantilever F tangent. So this will harm the actually, kalau if you don't do analysis, you just simply mount your gear for your machine design for power transmission. So you don't ignore what is actually the bending stress happen there. When you run your machine through times, at a certain period, then the tooth will break. The tooth will break, either break at this neck here, because of the bending stress. Also, the tooth will break. Now, this one is second part of the lecture because on the surface pitting. Contact surface, we have surface stress. That one on second part of our lecture. Okay, today we focus on bending stress. Okay, understand that class? So you have to calculate. Gears, you calculate speed ratio, then you do force analysis previously, and now you have to calculate the bending stress, and we have to find the safety factor. So bending stress, so you have to find the safety factor. So you calculate what is the sigma bending of this gear. Sigma bending of this gear, that is a formula I explain to you later. How we calculate the bending stress of this based off this F tangent. It means you must know, you must calculate your F tangent. This one you already know how to calculate your FT, right? So if you know your FT, then you can find the bending stress of the tooth. So we must make sure that our gear, not just simply we mounting gears like this. So we must make sure that gear to safe, when it runs. So it's safe when through times. Okay, so we have to calculate what is the formula. There will be a formula on there. I explain to you. Okay, that's basically a rough my briefing introduction about this. Okay, actually you look on this note. Okay, look on your class. Are you there? Can you hear me? Boleh online, okay?
Yeah,
okay. Okay, you go for topic 9 that is just download This one will be your lecture note PDF. Okay, gear part 2 Ada tak kelas? Download in your, open your e-learning You can see, I also share you my video, my old channel video. You can look under the video. That one kalau you don't understand, you browse to video YouTube that I share to you just now in the WhatsApp. I already recorded the one. Okay, open this slide note. This one. Ada tak kelas? Okay, let me share you.
Ada.
In PDF. Yeah. Okay, boleh nampak saya punya slide ni? Can you see my slide ni? PDF. Kelas. Chapter 9. Design of Measurement. Boleh nampak Ni, kelas.
Dia boleh nampak.
Alright. Okay, gear to strength. Okay, I told you this is about gear to strength because previously we learn about gear dynamic and gear train. You know how to do that, and also your punya gear forces. But kita don't end there. Kita tak end part 2 saja. We have to continue by calculate also the gear punya stress to calculate safety factor lah. Safety factor ni actually bila you dah calculate your bending stress, safety factor is your endurance limit of your gear because gear ni dynamic guys. Gear is in dynamic forces. It will be in fatigue analysis. So you have to calculate the endurance limit because the strength when gear is dynamic is rotating and it impact on the tooth of the upper gear. So it means that you don't do static analysis. Of course, you do fatigue analysis. If fatigue analysis, the strength of the tooth of your gear will be not SY. Remember, if fatigue, the strength will be endurance limit. Endurance, what the material the tooth can endure. So we have to calculate the SN. Remember the SN, CL, CG, CS, CT. CL, load factor, CG, gradient factor, CT, temperature, CR, reliability, CS, surface factor, temperature factor, CT, and CR, reliability factor, and also SN prime. But just SN, there is a formula. The SN is a little bit different. They punya factor, they have CL, CG, CS, and also they have KN that I explained to you. There's a certain factor to calculate your SN, endurance limit of your tooth, okay, the strength of your tooth, and also the sigma bending that you calculate just now. So that it will be the saturated. So this one will tentukan, this one will to make sure that your saturator is safe or not. Kalau below 1, theoretically is fail lah. Okay, this one how we do things lah, how we do in analysis. So we calculate the safety. Okay, let me kita go for introduction dulu. Okay, if you look in this note, as I told you, gear. Okay, if you look carefully, okay, this picture. Can you see this photoelastic image, class? Class diagram. Photoelastic image. Photoelastic image show the stress distribution and the stress concentration factor. If you look at they make a photoelastic image of this pair of gear tooth. Below is pinion, the upper is gear lah. So the pinion is driving the gear. So we have force. Nampak tak? We have force with an angle. Actually force tu is we have phi angle. You may remember your phi angle. We have force like this. If you look my video, force with at phi angle is your pressure angle. So we take the F tangent. That F tangent is actually here lah. So we take the component of the F tangent. F tangent is like this lah. This is F tangent. And also we have FR. Okay, we already learned how to calculate F tangent and FR from gear 3 to gear 2. So this is FT from 3 to 2. F tangent, this one FR. FR from gear 3 to 2. Okay, tetapi as I mentioned to you, for bending, if you look at this photoelastic image, nampak tak? There is a concentration, nampak tak? There is kind like what we call it is stress. What we call this gradient. Stress distribution. Stress distribution. Nampak tak? The focus. Can you see this one there? Ada stress concentration at that. That one, okay, that is a touching point of gear. That one is a surface stress. Itu part 2. Itu in our second lecture. We have to calculate the surface stress. No, for part 1, we focus on this one. If you see at the root here, at the neck, at the root here, we have both here. This one also we have stress concentration. This is due to the bending load by this F tangent time the length ni lah, the distance from here to here. This F tangent from the length of your gear ni, from where you F tangent, then we will have bending stress. Okay, this one will face tension of course because F tangent is from left to right. This one will be compression. Okay. So we have two parts of stress concentration. One is the surface stress. We later part 2 lecture. This one is bending stress. Okay, kita go for part 1 first. We go for bending stress. So what is this bending stress? How do we calculate that bending stress? Okay. All right, as I mentioned to you just now, okay, the two type of failure that causing the failure of the gear tooth, okay, we have, okay, just now, stress, okay, actually this one actually on the right surface of your gear tooth, right? This one on the left, actually the same, this one is the right surface. Okay, one is bikon patah. Okay, two primary failure modes of gear tooth, tooth breakage from excessive bending stress. Okay, yang ni at the bottom ni. This one lah, this one, this zone area ni, this one and here, bending stress. Another one, surface pitting. This one at the top, at the surface is where the impact. Yang this one, this stress concentration factor. This one part 2 in your lecture. Surface stress we also have to calculate. But now we go for bending stress. The bending stress will call breakage at the root. At the root, at the shoulder ni, at the root. Okay, normally when you go industry, bila you go for design, when gears, always gear through time they will fail. The tooth will patah. Okay, during my experience as engineer in Shah Alam, before I joined ETM, the gear tooth of one of the machine, our machine patah, break, the tooth break, the tooth break, the gear patah. So as engineer, you have to either what to do lah, to replace, macam mana lah, to solve that problem. Itu because tak analyze, you have to do engineers to make sure the gear stay safe, because it's overloading. Because okay, one is patah, terpatah is not because on the surface. The one ketika yang patah, the gear will break because of that bending stress here. It will happen, so make sure that we calculate, we want to be our gear 2 is safe. So surface pitting tu lah, surface tooth breakage based on bending stress. This one our lecture today. Okay, then another one because of surface pitting wear, it is contact surface at the top, excessive contact stress. This one part 2 on in our next second lecture. Okay, first we go for bending stress. Okay, for bending stress, for example, okay, if you look here, so we have force like this. If you look, we have force like this, F tangent here, as I told you, okay, F tangent, we have F radius, and this F tangent equal because of the length, okay, this is a profile of your gear tooth, gear tooth. So we have a height H here from the, from what we call it, from the fillet here, from the neck, okay, from the neck here, we have H, so actually, if you assume, let's say we assume that this gear tooth like a cantilever beam. For example, like cantilever beam, if you look in my live video, live video say okay. If you look in my live video, for example, okay, this one the cantilever beam like this lah. Okay, let's say kita assume roughly gear tooth is just like cantilever beam like this. Okay, this one will be your neck. Okay, this one will be your, you have F tangent here. So you have, here is F tangent, right? F tangent. And this one will be your H, the height of the where your F tangent acting on the surface of your gear tooth to the neck. That will be the height. And also the thickness is the total thickness here. Total thickness of here, this is a total thickness. And the B is the face width. The tebal of the gear. B2 is your face width, tebal of the gear. Normally, kalau we have F tangent, what will be the bending stress at this neck? This one compression, this one tension. So normally we know that bending stress is the bending stress. Okay, as I told you, the radial component too we negligible. We don't focus on actually gear. We have F radius, right? We have F radius, but this one it does not really affect on the tooth of your gear tooth. So we focus on the F tangent because F tangent that is the most critical that will cause bending stress. Okay, so the F tangent, if we calculate the bend stress, normally how do we calculate bending stress? Sigma bending is MC. This is a basic formula you must know, guys. MC over I is a bending stress. Okay, we know what is MC. MC is what is the moment? Moment is for we assume that if this is like cantilever, moment is F tangent times the length. Your F tangent times the length. So your length will be, your moment is your F tangent times the H lah. H is the length. Okay, and the C, what is C? C is actually, because cantilever beam, the cross section is a rectangle. So we take this is the neutral axis. So C, because since the thickness is we call T, so your C is T over 2. C over 2. So your C is T over 2. And your I, what is your I? I is, if you look on the this rectangular cross section, this will be face width will be your the H lah. We know I actually basic equation I for second moment of inertia is B, for rectangular is BH cube to the power of 3 over 12. So it means that B, actually, kalau biasa B is like this and D is B, this is H, but this one jadi T. So your I here is B is T and the H is B cube over 12. So you put here T B cube over 12, this will be I. So that will be basically, if you assume that the tooth is like a cantilever beam, just a rectangular beam. So it become like this. Your sigma bending basic equation is like this. But this one is kind of like if we simplify it, I just make it shortcut. If we simplify it, okay, that's what I explained to you just now. We simplify it and we because we have a rectangular ratio where your x is t squared over 4h. That because this is a mathematical punya dia lah. The orang kelas ada bunyi bising my home ni. Hold on. Okay, this x. Okay, this one just actually the substitute lah because of the ratio of the triangle. So basically we can rewrite the bending stress as like this. Sigma is FTH over BT cube lah. So like this one, if I cancel FH BT square, okay, we can rewrite it to our sigma is like this. Our sigma is, if we assume F tangent, sorry, sigma equal to 6 FTH over BT square. So that will be our basic equation for bending stress. But okay, but if you look at we have to, okay, at the end we have this formula. This formula sigma this formula actually replaced by sigma is tangent over F. F is your phase width guy. F is your ni. So you punya F ni is your, if you look on this, your F will be, this is F. In this equation, F, not F tangent. F is your phase width. B to actually F. Okay, actually F. So your punya sigma is F tangent. Your tangential load over F is your phase width, and Y is, okay, that is small y. Y actually is a factor, that already a ratio. Y is a, what we call it, a Lewis form factor, where your Y is 2x over 3p. 3 is your P is circular pitch. So what is circular pitch? So what is X and what is P? Your X is, X actually is mentioned here. X is your thickness. Okay, thickness over 2 over 4h. So it means that is X. So this is your gear tooth. Okay, your gear tooth. So this is your neck. Okay, your macam you akan cantilever beam. Okay, this will be your X ni actually, this is your thickness. Okay, because they already they make a ratio. X is your thickness of your tooth over 4h. This will be where you punya acting. H2 is where the acting of your F tangent to your root. That will be your H. So they make a form this ratio. X is t square over 4h. Okay, X is t square over h. Actually, you don't have to just to explain to guys, but basically the main thing you have to know what is the formula for bending. Just to why do they got this formula? So at bending equation is F tangent Fy over P. So Fy P. Y is what we call Lewis form factor. P is circular pitch, guys. P is circular pitch. P, the small p is circular pitch. Small p is your circular p. What is circular pitch? If you remember in your nomenclature of your, if you look on your gear like this, and the next gear tooth, okay, this is your pitch circle of your gear. Circular pitch is distant from the same to macam this point, at this point A to this point B. So this is the distance, this is P. That is circular pitch. Your tooth to the next tooth to the next tooth at the same point at your pitch circle diameter of gear. That is your circular pitch. Because they represent it. Because if they make the bending stress equation like cantilever beam, like I explained to you, FTH, T square, TB cube 12, they can be difficult to calculate because we have to measure the thickness and so on. Because gear, they already have modular, right, diametrical pitch or module in SI. what is circular pitch, diametrical pitch. So they simplify into the form of the gear to make it. That's why they name it Lewis form factor. Okay, from the cantilever beam, they assume that they rearrange the equation, they make it to y. Y is the, what we call it, Lewis form factor. Y is 2x over 3p. So they simplify the equation to make better, because here they have a table, like we know what is the Lewis form factor, they make a table. So that was called, if you look in this slide, we have sigma. Okay, we have two parts. For English we have, okay, our basic, this is basic equation for bending stress on gear tooth. Guys, are you listening or not, guys? Guys, are you there?
Yes, sir.
Okay, for English, pasal normally, guys, for your gears, if I'm not mistaken, for your exam will be in English unit, if I'm not mistaken, because basically most example kita English unit, or maybe symmetrical, you have to mainly, like I said, mainly in English. Okay, for English, the unit for bending stress is F tangent. F tangent is the tangent force applied on the tooth. Okay, follow you focus on pinion gear. You focus on gear, it will be different, guys. Will be different. F tangent time P. Also, they rearrange, because just now we have small P, circular pitch. Remember what is P? Bigger P too is actually diametrical P. Remember in your gears, kalau if you use metric, you use module, but diametral pitch, P is what? N over diameter. Do you remember, guys? Diametrical pitch, for English unit. Kalau SI, M, module. Module is D over N. Diameter, for English, diametrical pitch is number of this over the diameter of your gear, pitch diameter of your gear. So they rearrange the equation. The basic equation is that F tangent times the diametrical pitch, the B. What is B? B apa, guys? Apa B in here? Actually, what is B? B is class B itu face width, guys. Tahu Small b itu is face width, tebal, the thickness of your gear. Okay, guys. Understand? Class B is face width. B is face width. So they rearrange the equation become like this: F tangent times the diameter pitch, P time. Okay, this one called Y. Y is actually Lewis form. Actually, Y come from this equation. This one is small y. Okay, small y, but the small y is now y is 2s over 3p. Diametrical pitch 2x is the, where your x is actually there. This is a metric big represent. X is here, guys. X from the, because of the cantilever beam, that they actually there is x. Can you see that? Because the rectangle here, this rectangle, I don't need to explain to you detail. Just how they represent. They have got this rectangle and this rectangle actually the same ratio. This is a distant x. They got the x. Actually, this rectangle and this neck, this your F tangent. This rectangle and this again is the same thing, the same ratio. The same ratio. So this is a x. That is x. So x already put there. So x is your t square over 4h. T is, what is t? T is here. T is here. The thickness. Can you see this is the thickness of you? T over this is your thickness. So they make into that ratio. X is t square over 4h. Then they put into equation. Okay, you have Ft, Fy. What's y is now 2x over 3p. So what is your p? P2 is circular pitch. As I mentioned to you, your teeth and the next teeth of the same gear. This is your p circle diameter punya line. So at this point and at the same point, this is the distance of your p, because they already set the gear manufacturer already set the equation. So we don't need to just as a matter of explaining to you guys. So how they get. So this y. So they make it, this is capital Y. Y is actually capital Y. That's what Y. Capital Y is Lewis form factor is this small y over pi. So because small y, capital Y over pi is your small y just now. Small y. Okay. This is much better to define. So we have sigma F tangent times diametrical pitch over B over Y. That's why we call Lewis form factor. Okay, Lewis form, because easy. Because kalau if we make equation in term like this, sigma FTH, it's kind of like difficult to calculate the bending strength of gear too. So the gear ACMA, American Gear Manufacturing Association, long time ago, they already because they already have the the rearrange the equation, because gear they have dia punya ni lah, Lewis form factor. They're quite easy because Lewis form factor they have a table on that. So Lewis form factor already have been defined by through this explanation of this lah. So through this y. So y ni we can look from the table. So by Mr. Lewis form factor. Okay, this is basic equation for gears. Okay, this is FT. This one is for English unit, but for bending stress, remember your F tangent is up. Okay, is in your numerator, and denominator we have B is the phase width of your gear. But for mixed metric, the module is at the denominator. Just for English, you have diameter pitch is at the top lah. It's not at the denominator. The module is at the bottom, and times your Lewis form factor. This is bending stress for SI. Okay, this is yang top one to for English. So what is Y? Just now Y is 2xp over 3. Okay. 2x yang just now the ratio of the triangle x, that is Lewis form factor. Because this Lewis form factor, easy, they already set the table based on you. So you refer from the Lewis form factor. So gear tooth based on what is your gear tooth, and okay, this Lewis form factor. If you look on your, okay, by the way, your juvenile textbook on chapter 15, guys, chapter 15 on gears. Okay, if you look on figure 15.21, we have a table. This is what we call Lewis form factor. So you refer what is the number of teeth of your gear. For example, you have 34. So we go for what is the pressure angle. Remember gears we have either pressure angle is 20 degree or 35 degree. Okay, most of the case is 20 degree. If your pressure angle of your gear is 20 degree and the gear, okay, for example, the pinion number of teeth is 24. And the number of teeth of your gear is 24 and pressure angle there, so you can get your Y. Y is 0.344, for example, so on this Y axis. So you put that value into the equation. So you got your apa ni, your basic. This is a basic. Actually we because this is Lewis form factor. Because Lewis form factor, this equation, actually guys, because they must at this moment, when they form this Lewis form factor, they actually ignore the fatigue stress concentration factor. Remember guys, actually, because gear they have shoulder, right? They have shoulder ni, nampak tak? They have radius at fillet ni. Actually, there will be stress concentration. During Mr. Lewis form factor, they form this equation. They totally unknown about stress concentration. Because we have shoulder, we have radius. Because we have stress concentration factor. Because since this one is just a basic equation, a long time ago they used the equation to calculate the bending stress. But after they consider the fatigue stress concentration factor, so we no longer use this equation. Actually, they modify this equation. F tangent time diametrical pitch over B, not Y. Because Y actually they ignore the stress concentration factor. After they consider stress concentration factor, so they replace the equation that we will use is actually as shown in your slide here. Okay, this is gear tooth fatigue. Okay, because now we consider fatigue. Because gear, of course, fatigue. When we consider fatigue stress, we must also consider, remember when we have shoulder at the tooth, at the neck of your gear tooth, there is a radius, right? Radius fillet, radius fillet too. There will be stress concentration. After considering fatigue stress concentration, the Y will be replaced by J. That's why gear tooth, bending tooth fatigue bending analysis. So this is a question that you will use for your bending stress. For this one for English, guys, ini equation because diametrical pitch, this one will be English. Your sigma will be PSI. Sigma will be bending stress. It's not megapascal. It will be KSI or PSI. This one is English. So for English, so our bending stress is actually sigma is your F tangent time diameter pitch over B is B. What is small b? Small b is the phase width of your gear. This is your gear, okay? Isometric view of your gear. Okay, this is your gear profile. So this one, the thickness, this one we call B, phase width, phase width. There will be your B. Okay, sigma is F tangent, your tangential force. Okay, this is your tangent, F tangent here, F tangent, times diameter pitch. So why diameter pitch? You already know diameter pitch is N, number of teeth over the diameter of your gear, pitch diameter of your gear. So you know how to calculate. If you know a diameter, then you can get your diameter pitch, or is given in the question. Okay, over the B, phase width of your gear times the J. Okay, the Y Lewis form factor have been replaced by J. J, what we call spur gear geometry factor. We are no longer using Lewis form. Lewis form factor is long time ago because they totally unknown about stress concentration factor. Remember when do fatigue, we have stress concentration. stress concentration factor. For shaft, remember when do KF is 1 plus Q, KT, Q times KT minus 1 in bracket. That will be your KF. Then KF will be multiplied to your stress. But this is gear 2, the profile, so the J is already, they replaced the Lewis form factor has been modified to take consideration of fatigue stress concentration factor. That's why J is per gear geometry factor. Okay, J is spur gear. This one has been explained. Kalau you know, in my video I already explained. You look on my YouTube video, I already explained on it. Okay, J will be spur gear geometry factor. You look on it. So if for you to calculate bending stress, okay, you know your F tangent, you know your metrical pitch, you know your phase width, always given. Okay, always given the J. First you calculate your J lah. J is spur gear geometry factor. Spur gear geometry factor in figure 15.23. Chapter 15 in your textbook, Jaminal. Okay, refer figure 15.23. Okay, 15.23. If you look, okay, let me open our textbook. Hold on. Okay, let me share you the textbook. Kau boleh nampak the textbook kelas? Hello class, are you there?
Ya, boleh nampak.
Textbook kita gear in chapter 15, right? Okay, chapter 15, before this we only up to gear forces. Okay, chapter 15, case per gears, figure apa tu? Figure 15, this is important for, okay, there have to, one is 20 degree for angle, figure 15, apa figure number ni? Figure 15.23, figure 15 in your textbook, figure 15.23. Where is it? On page berapa tu? Figure 15.23. Ni guys, in your textbook, page, ni you highlight this thing, page berapa nampak? 585, 585, okay. That is how you get your J, okay? Because sigma is Ft times P, B over J. Then we have another factor, Kv, K, I explain later. Okay, the J, your spur gear geometry factor. We don't use actually, Lewis form factor is just explanation to you. Previously is Y, but rearrange Y be replaced by J because we take consideration on fatigue stress. Okay. So what is that fatigue stress concentration? I already explained in my YouTube video, but I don't explain it here lah. But just for you, okay, that's explanation about J. You can look on my YouTube video. I explain why is it J actually replace Y. Okay. Okay, that J is spur gear geometry factor. After consideration fatigue stress concentration, then we got our J. Okay, this is a figure 15.23. Okay, you tengok Okay, let's say for example your opinion. We have two types ini. We have two zone of graph. Okay, your x-axis is the number of teeth of your gear. Okay, number 3, and this one. Okay, be careful. When you use this one, this is pressure angle 20 degree. Be careful. If the question say that your set is pressure angle phi 20 degree, so you use this graph. But if your gear set is 25 degree, the whole set, and when you have a set of gears, all must be the same module, all must be the same diametrical pitch, and all must be the same pressure angle. Okay, you cannot have, okay, your pinion pressure angle 20, your bigger gear is 25 gear. No, okay, you cannot be matched. Okay, must be the same. Everything, okay, if your pressure angle, okay, pressure angle phi is 20 degree, you use this one. Kalau if your pressure angle is 25 degree, given in the question, use the second graph. Be careful about that. Okay, we have two zone here. We have two zone. Okay, we have two zone. Okay, this one load applied at tip of no shearing. Okay, either which, okay, so okay, let's say my gear is 20, okay, is for example like 24. 24 is the tooth number of teeth on my gear. So which one? Do I need to use the upper graph or the bottom graph? Okay, the bottom graph is the most commonly used because if your gear load applied at tip no shearing, load applied at tip no shearing, this one is not less precision gear. Okay, the one is for high point of ni. Highest point ini yang contact shearing. This one is for precision gear. It mean the gear tu really that is load sharing. This one load applied at tip. This one is not load sharing. So most commonly, kalau your gear is just like a gearbox, not a high precision gear, you use the bottom graph. Okay, and this one load sharing. It means the distribution of the force is really accurate and really precise. Highest point of single contact sharing. But is it, if it is mentioned in the question, it said is a load apply high single tooth contact sharing. The sharing, okay, it means we use the upper graph. If no sharing, the most commonly we use the bottom. But you must read the question, okay? For example, like you punya number of teeth 24, you go for the second graph here, then you bring it here. So this one is 0. Lebih kurang 0.255 lah, lebih kurang here lah, 0.25, 26, 27, 28, lebih kurang 0.26. For example lah, 0.26, that will be your J. Here is J. Okay, guys, that's how you calculate J for this question. So that will be your J. If you know, J is your spur gear, refer figure 51. Okay. Okay, we have J there, but we have another factor. This one is bending stress, KV, KO, KM. Okay, this also, you need to consider this thing. KV is a velocity factor or dynamic factor, KO is overload factor, and KM is a mounting factor. Okay, because for gear bending stress, you have to calculate bending stress. Then you calculate your endurance limit. Okay, what is KV? KV is your velocity or dynamic factor. Because gear, guys, gear the impact, because gear tooth mesh with the pinion gear and the gear. So the gear tooth is in dynamic, the impact, dynamic factor. Because they are in dynamic, they will impact. The gear tooth will impact on the tooth again. They will come. They will keep in dynamic, velocity dynamic. So dynamic factor that. So we have KV. So what is KV? Dynamic factor too, you can, KV is okay, if you look on your figure 15.24 in your textbook, so you have a graph. Either you can use formula or you can use graph, but it depends, I think, guys, it depends on the type of machine of your gears. If you look in figure, if your textbook figure 15.24, where is it? Figure 15.24, 15.24 here. Okay, if you look, nampak guys in your textbook, figure 15.24, page berapa ni? Figure 15.24, page 586. Okay, this where you can get your KV. Okay, you have, okay, this, if you look on this graph, okay, we have x-axis and we have y-axis. Y-axis where you find your KV, your dynamic factor, velocity factor. So we have, okay, it depends on how the gear been manufactured. Normally gears, guys, they are using hobbing. Normally gears, they are hobbing with cutters. Hop from cutters. There are the hop from cutters, hop shaping cutters. I need precision. If you more go downward, precision, shape, and ground. It means the gear tooth after they hop. Normally gears, you know what is hobbing, guys? Gear hobbing, if you look on the, hobbing is the process of gear like this, guys. Gear hobbing. Let me share you. Am I sharing you the file form? Boleh nampak file saya punya YouTube, guys? Kelas.
Ya, boleh nampak.
Hobbing ni, normally how they make this gear, they have cutter, this simple gear hobbing machine. This is the machine. They have, okay, that's how they have a cutter. Okay, I off the sound. They have the cutter. Dapat they cut. This normally your gear is a plank cylinder. That's how they cut it. Nampak tak? There is a cutting while the plank is rotating and the cutter, they will cut until at the end it become a gear tooth. Can you see? They will cut. This is what we call hobbing process. This is what we call hobbing. But this, okay, at the end until they have this one. Tapi this one is not spur gear, this is helical gear. Tapi the process is same, hobbing, because the tooth is to make helical gear. But spur gear is the same. That we call hobbing. That's why they're shaping the gear tooth. Okay. Okay. If you look back on the so this one, okay, hop from cutters, and okay, if you go for zone E, line E, zone area E, hop from cutter. This one is just basic rough manufacture gear, not that precision gear, not quality, not that good, just a typical, as long the gear can drive another shaft as a power transmission. It's not like a precision one. This one hop shaping cutters. This one a little bit hob shaping cutters. It means that little bit better. They're hobbing and they're shaping the tooth. Okay, this one precision. After they cut, they precision, they shave the tooth and they grind it. More precision. I mean the gear to the tooth, the more quality in terms of, sometimes again they need to be really precise because you want to maintain the really constant velocity. Remember I said the gear is better than belt. Belt, if you want to maintain constant velocity, you use gears. But gear also they have category. Yeah, the sometimes the manufacturer they really the profile, the shape smooth and they need the efficiency need to be high. The less friction, the shave and the grind the surface the tooth. Yeah, this one more high precision, zone B, high shave and grind. This one the highest precision. Okay, the more high precision is zone A. Okay, so this one will affect how you get your KV. So first, your x-axis is your pitch line velocity. Remember what is your pitch line velocity of your gear? You can get your V here, right, guys? So what is your class? Are you watching my live video? Gear, okay, gear is rotating like this. This is your gear. So ini, your ni. Because this is your end, right? So this is a V. Remember equation of V, right? In question 4, what is V? V pi dn over, in English unit, right? Your V velocity, I cannot get pi dn over 12 feet, okay? Okay, basically V is, kalau in physics, basically V is R times omega lah. Omega is actually your N, okay? Angular velocity, that will be your pitch line velocity. So your opinion, you analyze it on your opinion. So calculate your V. You can remember in question, I cannot recall guys, sorry, in your notes slide point, ada kan? Pi dn, correct me, over apa? Over 12 ke? Class. Are you there or not? Kau ni ada ke tak ada ni saya bercakap ni kelas?
Ada doktor.
Kan V kan, how to calculate V tahu kan? Tahu kan this one, pitch line velocity. Kan remember power is Ft times V kan, how you get from V, then you got your F tangent. Remember you do fast, you got your, that will be your V guys, your pitch line velocity. Okay? Ni I bought 12 ni, saya tak sure, correct me if wrong, look on your net for pi dn. This English unit based on English. Metric, the metric is pi dn over berapa tu I check. Okay, for English you calculate your pitch line velocities and what is, okay, for example you want to use hop shaping cutter. So okay, let's say you calculate your pitch line velocity about 2,500 feet per minute. So you are using hop cutters. So you can get it like this. So this will be your KV. Okay, actually guys, sebenarnya kita tak use sangat this graph. So okay, this graph only, kita actually not use graph to find KV. This graph only to make sure what zone are you. Okay, if you said hop shaping cutters, you are zone D. Okay, the first is E. Hop from cutters. Hobbing process. So I show you the video, that is hobbing. That is hobbing process. Form cutters. Form cutter mean they form the shape. Form cutter ini little bit less quality dengan shaping cutters. They just form as long as they got shaping. It mean they're more shaped, more accurate. Shaping cutters. Okay, they have another process. Okay, let's say hobbing process, shaping cutters. Cutters, it mean the cutters of the one that cut your plank of your cylinder to make a gear. That cutters to shaping, they shape it. This one normally is typically I think gear is more hobbing shaping cutters lah. General gears lah. If said okay, you are in D zone, D area, D type D. Type D, okay, you can go to get your KV, use equation. Actually, you don't use graph. The graph to show what zone are you. Sorry guys, actually from there you get KV. Actually KV you can get. Okay, if you are D, is D, that it means that you use D equation. Understand that class? This one, this equation. So your KV will be 1,200 plus V over 1,200. Yes.
So if we put the pitch line velocity from down, where should we stop the line?
Pardon? Apa?
The graph above. Okay, if we pull from bottom, where should we stop?
Yeah, I understand what you mean. Where do you stop? Yeah, we understand. No, actually, they punya shaping tu lah, the way this graph, where do we stop? Yeah, you are right. Where do we stop? Okay, let's say 2,500. Where do I stop? Where is my KV? Actually, this one, you look on this graph, okay, the question or you design for your major project, for example, you assume, okay, sir, for your major project, foot mixer kan, I want to use gears. So what do I use? Gears. Normally for general gear, if your machine foot mixer, your gears just to drive, it's not precision machine, guys. And foot mixer is not precision. Okay, you use gear. Okay, so I want to use gear instead of V-back and pulley. Because why? You have reason. You want to make it, because gear is much better in terms of accuracy. You assume, okay, let's say you and your group assume that the drum of your foot mixer, let's say you make some example, the food technologies from Nestle, that will be your client, they need really accurate to be 60 RPM. Yeah, you mentioned, you justify in your report. That's good for me. I mentioned you put into the real situation. Because guys, this is like consultancy. You do this thing, this engineering consultancy punya job. Okay. So, okay, you said must be accurate. So you use spur gear instead of V-bar. Okay, spur gear. So, okay, spur you want use gear. So which one, sir? Hobbing ke, precision ke? Normally yang ni lah, this one, D. Okay, the graph is meant to for you to what zone are you? Just to show what category. Actually, you cannot. Where do we stop? Yeah, right. Where do we stop here? So sorry if I cannot recall. Maybe saya tak boleh recall sekarang. What is the reason they use this graph? Where do we stop? Can? Yeah. So we start. Normally we use this question. Okay, if you let's say you want to use hobbing, shaping cutter. Mainly, generally is D type. Okay, let's say in the question is already given. Okay, use D lah. This you use the question to get your KB. Understand? Clear? So this is how you use KB. Class, are you there?
Ya, Dr. Okay.
Okay, yang ini okay guys, bawah ni is English V. Top one is metric. Your V in meter per second, right? Your V, V, you know how to calculate your V kan. So you are using D. So that's it lah. You use KB. V, not V is in feet per minute. Okay, to ask about your question. Okay, D is B in feet per minute. Sir, can I use this one is my V in meter per second square? Be careful lah, you have to read it first. Nanti dulu, saya I cannot recall guys. Ini, okay, this equation valid for metric or never mind, you just use kV because kV is just a factor. No, there's nothing different. You convert, okay, your V is the same. It's the same because kV is not what you need. kV is just a factor, unitless. Unitless. You can use either V or in meter per second or feet per minute. Okay? Okay, understand? Class? Clear? It's just a factor. You can use the same. Okay, kV is 1000 plus B. Okay, if you are zone D, normally it's D. But be careful. Sometimes in question they said, okay, high precision gear, shave and ground. I mean high precision gear. So you have to use B. So B will be this one. They will be. Okay, sometimes also equation, okay, you have to look, guys. You don't depend on not. You baca, make sure you read this part under topic ini. KV velocity diameter indicating survey of impact. Okay, so okay. Figure 50.24, this one. Okay, explain. Okay. Okay, for reference, curve A is ACMA quality control number class. QV is 9. Sometimes the question said, sometimes the question isn't mention to you about hobbing, shaping cutters. Hobbing, shaping cutters. Dia cakap QB. Dia cakap quality control for ACMA is QV9. QV9, okay, this is ACMA setting of the quality. QV9, this is ACMA setting. QV9, curve B. QV6, curve C. Understand, class? QV6, curve C. QV4, 9 in bracket. QV4, 9 in bracket. Mana dia? 9 in bracket apa? 9 in bracket means ada reference ni. Okay, biasa. QV9, okay, this is a curve, quality control number from ACMA. Now, sometimes I mention this. QV9, you use curve B. Curve B lah, use curve B. Ini high quality lah. If you QV6, quality QV9, curve B. For QV6, curve C. Okay, you also must read ni. Class. Take note class. Hello, class.
Ya, Doktor. Ada.
Baca ni juga. This one also you must read this one for your KV. And also, based on sometimes cakap hobbing, shaping cutters. D lah. But high precision, it did mention high precision, shave and ground. B. Kalau highest precision, A. Okay. Kalau A, use A question. Kalau D, B, depend. Okay, that's for KV. Alright, KV is KV Okay, KV. The next will be, after KV is KO. KO is overload factor. Overload factor, it means the way how your machine drive and driven. Remember for you back, you punya drive, you can get your factor. Same goes for gear, your overload factor. Okay, always overload. Table 15.1. Table 15.1 in your textbook. In your textbook, ini. Table 15.1. Ni, page 587, take note. In your textbook. Okay, source of power. In your project, you use typical motor electrical typical like DC motor. Actually, the source of power is uniform. Unless kalau you use, for example, I remember we doing example on VBEL, the construction side, they are not using electrical motor. For sometimes like heavy duty, 25, 55 horsepower for construction, they need engine, not electrical motor. They drive by fuel, petrol. Engine, that one source of power dia little bit like shock tau guys, dia bukan uniform. Source of power like shock, dia bukan uniform. Electrical motor normally uniform, like shock. Kadang-kadang ada source of power. This what we call source of power. Okay, driven machinery, your machine. Okay, your shaft A connected to the motor. The driven, your shaft B is your driven, your machine. Your machine tu, okay, for example, you are foot mixer. Foot mixer apa? Uniform shock or moderate shock? Class. Okay, you punya motor electrical lah, of course you use uniform. Sometimes, be careful, sometimes motor you buy from industry, they did mention in their spec, dia punya shock dia kind like dia bukan uniform. Be careful about it. Tapi normally you go for uniform lah. Okay, you punya foot mixer apa? Driven machinery, shaft B. Is it uniform or moderate shock?
Uniform.
Are you sure uniform? Uniform ni gearbox tu, uniform ni like you just want to power transmission je, change speed ratio.
Like shock.
Yeah, I think it will be moderate shock. Pasal your shaft B drive your machine. Your shaft B, maybe your shaft D tu you have blade. You have kind of like spiral blade to mix the food. You don't think, because if your food is liquid, katakan you just make a liquid, everything is liquid, yeah, it could be uniform. Tapi I don't think so. Food mixer ni you have maybe, I'm not sure what food your project is, about food mixer, what is the food you want to mix. This one you define, nanti you define in your report. You must mention what type of food mixer. Okay, let's say it's a granular. Maybe dough also is a food mixer, dough. Remember dough, before I give student dough flattener, but yours is dough, to mix the dough. That one is not uniform. Dough tu they have ada impact lah. There will be impact dough because they have kelikatan, what we call the dough. It will be moderate shock. Maybe heavy shock is more on you crunching. That one no lah. Like to crunch the woods, to crunch the stone. Itu yang heavy shock. Kayak like crunching machine. You more on 1.25. That will be your KO. Okay, source of power is source from your source of power lah. Be careful, but so 1.2. That will be your overload factor. Okay, the next is apa tu is KM. KM is a mounting factor. Mounting factor, guys. Okay, mounting factor from table 15.2. Mounting factor is table 15.2. Table 15.2. Okay, table 52 in your textbook on the same, 587. Okay, mounting factor. Okay, this one characteristic of support. Accurate mounting, small bearing clearance. Ini less rigid mounting, less accurate. Ini accurate mounting, small bearing clearance, minimum deflection, precision gears. Okay, the second one is less rigid mounting, less accurate gears, contact across full surface. This number 2. Number 3, accurate mounting such that less than full face contact exists over 2.2. It means this one accuracy. This one is the bottom one is the less accurate. The middle one is the medium accuracy. The top one is the most accurate mounting gear. I mean accurate, small bearing clearance, minimum deflection, precision gear. So mean guys macam ni guys, mounting, the way you mounting your gear tu, okay, the way you mounting. Kata let's say for example, like say your project foot mixer, you need to be accurate mounting. You want to be precision gear, so you go for first one. So okay, let's say this is your this is your face width of your gear. This is the face width of your bottom gear. Bottom gear, your shaft A. So this is your shaft A, guys. So I'm talking about plan view. So this is your spur gear teeth lah. So this is your spur gear teeth of your top gear. This is shaft B to drive your machine. Okay, the mounting accuracy. Remember I cakap misalignment. Okay, for example, you really need to be. I mean, kalau the teeth of your pinion and the teeth of your gear at the top, it mean the, you know, your actually your force tangent, guys, is a uniform force because we have phase width, right? B is your phase width. So I mean the F tangent apply to F tangent that apply is uniformly. So it mean accurate mounting. Okay, the less rigid, the second one rigid, less accurate gear contact across, but gear contact across. Okay, this one also the gear force F tangent actually is uniform, guys. We take the total force actually because gear we have thickness, right? Okay, the second case also yang the force really uniform across full surface. But the worst case is the less accurate. Accuracy, it means the sometimes, okay, the gear and the top gear, the F tangent to actually they're less uniform lah. They're less accurate. What am I call less accurate? So less accurate you use over 2.2 for all cases. Okay, for example, your accurate mounting. So you punya, this is your face width in inch. Okay, face width. You know what is face width? Face width is your B lah. The thickness of your gear, face width. Okay, it is stated 0 to 2, you use 1.3. If your face width is inch, 1.4. This is how you do it. Okay, guys. So kalau yang ini is a middle, less rigid mounting, less accurate gear. Okay, sometimes the question always stated. You read the question. Less rigid mounting, less accurate gear, contact across full surface. It's mentioned, make sure that. Okay, kalau face width is 0 to 2, use this 1.6. If face width is 6 inch, 1.7. Face width is 9, 1.8. Okay, greater than 6, 2.2. Okay, guys, that's about your km. So that will be your equation for your bending stress. Bending stress. Okay, hold on, class. Saya sikit lagi lah, pasal kita break sekejap. Pasal kita 3 hours, kan? Betul tak, guys? Kita bending stress. Remember, class? Bending stress, class. Are you listening or not, class? Hello, class. Your sigma bending, kita only calculate sigma bending. Kita belum go for SN. SN, remember, AN, CL, CG, CS, and then for your shaft, right? But gear a little bit different. We only, because safety, that at the end, safety factor. Safety factor is your SN over your sigma bending. Sigma bending is apa? Your F tangent times P over B times J. J is per gear geometry. You know how to do. P is diameter of pitch. N over diameter of gear. KV, KO, and KM. Okay, KM is KM mounting factor. KM you can get. That will be your sigma bending stress. Alright. Okay, remember at the end gear, we need to find safety factor. Safety factor where is your N is your SN, endurance limit over your sigma bending of your gear. So your sigma bending, you calculate it in PSI or KSI, English unit. Metric is megapascal. Okay, will be in your denominator. But what about this SN? So why is SN? Okay, SN to the denominator, so you have to this. Okay, SN, okay, in your notes, this is your SN. Nampak kelas? Class this is your SN. Endurance limit of your gear. Okay, SN, endurance limit of your gear tooth. So SN, okay, SN endurance limit is your SN prime. Actually, we have CL. CL, like shaft and load factor, we have gradient factor, size factor, we have surface factor. This one is the same. Size factor, but kita don't have CT, CR, they be replaced by gears. KR. KR is the reliability factor. CR gear is KR. Gear is KR reliability. KT is the temperature. Same like shaft. Actually, CR, CT lah. Tapi gear little bit KR. We use table. Not table from chapter 8. From KR ni reliability from table chapter 15. KT is temperature from table chapter 15 also, not chapter 8. Chapter 8 is quite thicknesses, right? And your KMS. Ini is your means, KMS is your what we call it mean stress factor. This I explain to you. Okay, CL is just a typical. Remember when you do load, CL is a load factor because gear is always bending. Remember, kalau shaft, if you have load, you use table 18.5, I'm not mistaken, table chapter 8, right? For load, for axial different, for torsion different. But gears, because gears, this is your gear. Gears, the one that we calculate is bending stress. F tangent, this is always bending load. This is always bending stress. Okay, bending. So CG, so because CL, this one, sorry guys, ini kena times by SN prime. Remember, SN prime is your standard test. Standard test Aramo endurance limit is always 0.25. Your SN prime ni is 0.5 for steel. This is valid for steel. 0.5 SUT. Okay, 0.5 ST for steel. SN is armor endurance limit. Depend for steel. This one only for steel is for different material line, not 0.5 of your SUT of your gear. You know the material of gear, you can know your SUT, right? So you 0.5, that will be your SM prime for steel. Okay, your CL is only load because always bending. Gear bending, CL is always 1. CL is always 1. Your CG gradient factor. Okay, CG is gradient factor. It's already stated here. CG is 1 for diametrical pitch greater than 5. Okay, for CG, this one you don't refer to table in your, remember your chapter 8, table 8 point berapa to 8.5, not sure. Okay, CG is 1 for diametrical pitch greater than 5, but CG is 0. Either ni saja, you used to be either 1 or 0.85 because diametrical pitch, remember guys, diametrical pitch P is N over D kan. Either is given in the question or you set. Okay, if your diametrical pitch greater than 5 inch, sorry, P is N over D per inch. Per inch is 5 per inch. If your P is given greater than 5, your CG is 1. If less than 5 inch, CG 0.5. So CG we know lah. I ada that to be either 1 or 0.85. Be careful about your diametrical pitch here. So okay, S is surface condition factor. Surface condition factor, you have to look on the yang surface condition, you have to look on the, not on your chapter gear. Your surface condition factor is is your on your fatigue in your chapter 8, surface factor. Nanti kita discuss about sample problem nanti. Chapter 8, remember your surface factor, you get yourself, that's the same thing, surface factor. Okay, KR is reliability factor. KR is a reliability. Reliability factor, you don't use chapter 8. Reliability factor, you goes on table 15.3. Table 15.3 is here. In your textbook chapter 15. Table 15.3 is here. Okay, page 588. Okay, this is reliability factor for gear. This is for your KR. Okay, if it is not given, always reliability 50% is 1. KR is 1. Kalau for example 99%, 0.184. 90%, 0.897. Okay, the highest reliability factor, it means the lowest will be your factor, because if the highest quality, the reliability aspect to be high, it means lowest you punya KR. So you mean your endurance limit is lower. So safety factor is so you mean your safety factor is endurance limit is lower. Kalau the highest you aspect, it means you punya safety factor will be reduced. You have to be careful. You really need to ni. Okay, it's given. Okay, given reliability, use this table. Okay, that will be your KR reliability. So what about KT? KT is a temperature factor. Temperature factor already mentioned, guys. For KT equal to 1, if your temperature is less than 160 degree. Okay, KT is 1. For less than, if your operating temperature, your machine 160 degree Fahrenheit, less than that, you use KT1. Okay, if your, let's say, it's really high temperature, your surface surrounding, your environment surrounding, you punya, maybe you operate at the furnace, something like that, really high temperature, for greater than 160, so you use the formula, 620 over 460 plus T, this will be your KT value. So in your textbook, it's already, we have formula on this. Okay, that's one your temperature factor. For less than 160, use KT is 1. For bigger than 160 degree Fahrenheit, use the equation. The value of temperature is in Fahrenheit. Okay, let's say you are 180 degree Fahrenheit. You put the equation, so you get your KT. All right, so that's what your KT. Okay, the last one, KMS. What is KMS? KMS is a mean stress factor. Mean stress factor. Okay, mean stress factor. Mean stress factor means like this, guys. Okay, KMS ni is use one for idler gear. Kalau your gear is, okay, because all gear you need to analyze of the tools. If the gear is idler at the middle, the KMS mean stress factor is 1. Because idler gear always subjected to two-way bending. Okay, the 1. But 1.4 for input and output gear. So something like this, guys. Sini. Guys, are you listening? Look carefully. Please look at my video. My live video. Class, are you there?
Yes, can see.
Okay, this is your gear. This is your input gear. The center is idler gear, and the third gear is the output gear. Okay, idler gear is always center. They're meant to either behave as an idler. So this is your gear 1. Okay, let's say your gears goes this direction. Idle gear goes on this direction. And gear 3, the output gear goes like this. Okay, idler gear. Why idler gear? Dia KMS. We are talking KMS, the main stress factor. KMS, KMS, main stress factor, because it is 1. Because idler gear, okay, we look input gear. Input gear and output gear is not. It's not idler. Because, okay, let's say the tooth, okay. This is the tooth of your input gear. The tooth of your input gear. So, okay, this is the tooth. I just draw one tooth only. Bila the gear is turning like this, the tooth of gear is, okay, the surface is at this right surface of the gear, right? When it will impact the idler gear. Okay, so we have N tangent, this direction, F tangent is direction. Impact from the gear idler to your tooth of your input gear. So the tooth will go to the circle again, one rotation, then we have the same, at the same surface. At the same surface, I mean the surface at the bottom only. So it have, if you plot the bending stress, they become like this. They only on tension, positive saja. Sigma bending. Betul tak guys? Like that saja. Like that saja. That one for input. Same goes for output gear. Output gear also the same. Output gear, okay, the tooth from the idler, okay, this is the output gear, the gear number 3. So this is the tooth. Okay, so this is the, because the idler gear is driving the, so this one is F tangent from the idler to the, I'm talking about the last gear, the output gear. The output gear, input gear, say, they have only at this surface saja. So the gear will go here, and this one like that. Okay, sorry guys. The tooth of the output gear is like this. It will drive like that. So it will rotate like this. It will rotate like that, and apa tu? Sorry guys, this one direction. Same goes yang ini, dia akan impact like this. This one will impact. Okay, this one will impact. Will goes like this. So this one will impact. So this one also, this tooth, when we go, you have the one, because when we plot through times, your sigma bending is just like one way saja, one way. But unless the idler is at the middle, At the middle gear, okay, this is the idler gear here like this, and because the impact from the driver gear, from your input gear, so your tooth is like this. Okay, once your tooth, they have impact like this. Okay, impact like this. But when the idler, when it goes this direction, when it goes like the same tooth, I'm talking about the same tooth. When the tooth go to this position, okay, this one at the top surface here. But when it goes to this position, the top surface become bottom, but this other not. This bottom surface here become top, but this one, it will receive impact from the output gear. So it means both of the idler tooth, this one we have F tangent at this. So F tangent is at the top surface. When it goes to this direction, until the top surface become bottom, but the top surface not have impact from the tooth of the output gear, but at the other surface. At the bottom here become top. The other surface have the impact. It means the tooth of the idler gear, when plot through times, they like this. They have tension and they have compression. They have tension, they have compression, the sigma bending. So that's why sigma ms for idler gear is 1. Because they mean stress. Mean stress, it becomes 0 here. So I mean they set for idler gear, the KMS mean stress factor is 1. But for input and output gear, they have the mean stress is not 0. For idler gear, the mean stress is 0 because the two have tension and compression, so the mean is 0. But for input gear and output gear, the tooth remain on the same surface, because tooth of the gear, they have which surface already have impact. When they goes the same surface, it means they have one positive, where they have apa? Your KMS is not have they don't have a negative side, so they only have positive bending. So they mean dia punya sigma mean, the mean is much higher. That's why the KMS is 1.5 for not idler. Okay, because when you have a set of gears, like this one, small gears, and this one is not ideal gear. So the question is like this, or left and right like that. So both of these two gears is not ideal, unless for in the middle. Ideal gear, yes, your KMS is 1. Okay, KMS is 1, but for input and output gear, typical gear is input output use 1.4. Okay, class clear, eh? Fine, that's explain why, okay, either one only. Be careful on that. 1.5 for input and output. Normally case input. Unless your gear is idler, you need to analyze the bending cell of that idler tools, use 1 for idler gears. Right? Okay. So that will be our SN. Class, are you there or not, class?
Yes, okay.
Okay, kita break sekejap boleh sekejap break. About 10 minutes. Boleh, kelas? Kita
Boleh,
sampai
Pak.
5 kan? Break sekejap. Okay. Before we break. So, we know our sigma bending is Ft times P over B K K apa? KO KV KO KM kan? Betul kan? Bending stress. KV KO KM. Okay, KV KO KM. Okay, velocity factor, overload factor, mounting factor. Then you get your sigma B, and your SN is your CL, CG, CS, KR, KT, KMS times your SN endurance limit. Okay, that will be your endurance strength of your gear. That will be your SN prime times CL, CG, CS, KR, KT, KMS. So you calculate this both. You calculate this both, so you get your safety factor lah. Safety factor is your SN over sigma D. That's how you do analysis on bending. Okay. So that's how you do. Typically, all the question is given, all the punya tu, all the statement, all the parameter is given, then you just simply calculate. Like the metrical pitch is given the question. Your like in metric module, F tangent to you calculate. J to be number of teeth, you can get your J. B space width always given. Space width 2 inch, 3 inch space width, the width of your gear. And you can find sigma B, and you can find your endurance limit, then you calculate your safe factor. If greater, theoretically greater than 1 is safe. So that's how you do it for bending cell. Okay, kita break sekejap. Okay, for 10 minutes. For boleh 4-10 minit kita come back. Class.
Okay, Doctor.
Okay, kita break for 10 minutes. Okay, Assalamualaikum. Class, are you there or not? Right. Okay, shall we continue? Okay, class. Okay, let's continue. Kita go for sample problem. Actually, in your slide, lecture slide tu ada. Okay, we go for, as I mentioned to you, safety factor if your SN over your sigma bending. Okay. Alright, okay, make sure when you design, you do analysis, make sure that your safety factor, because we already consider overload factor in gears. Guys, are you listening or not?
Yes, listening.
Okay. So basically, this is a question, your endurance limit over your sigma bending. So since factor KO, overload factor, mounting factor, and KR, reliability factor, have been taken into reliability factor, make your reliability 99%, 95%, have been taken into account separately. The safety factor need not be, take note, as large as would.
Sir, are you sharing anything?
Oh, I'm not sharing. Okay, sorry.
Oh, okay.
Okay, sharing the notes. Kau boleh nampak the notes tu? Your notes ni. Kelas.
Ada nampak.
Boleh nampak? Okay. Since the equation is safety factor is your endurance limit of your bending stress. Okay, since KO, remember your sigma bending is Ft over times P, WTP over Bj times Kv, Ko, Km. And we already have KO, Km, and also your SN, we have Kr. It already taken into account. the safety factor need not be as large as would otherwise be necessary. Understand what I mean? So don't set your sensitivity too much too high. Typical safety factor of 1.5 might be selected for gears. Okay. When you calculate your safety factor, 1.5, 1.6, don't for like 6 point something, 4 point something, because maybe you are too much waste in terms of the strength of the gears. Okay, together with a reliability factor corresponding to 99.9% reliability. Okay, because with the KR, let's say go for 99.9, and so you mean your reliability you expect high. So I mean when you calculate your safety factor, need not to be too much. About 1.5, 1.6, 1.7 for gears is quite okay, but not 1.1, 1.2, no, because that is close to border of failure. Okay. All right, let's go for okay, typical sample problem. Okay, now if you look in the sample problem, we have okay, this is a plan view of the gears. Okay, if you look, the top is a pinion and the bottom is a gear. Okay, the pinion is driving electric motor 1720. Okay, it's given the electric motor, but in this problem they don't give the power. What is the power? But they give the motor is 1720 RPM. Then also we know power is torque times omega. Okay, the torque also was not given. So the power by only give the speed of the motor 172 RPM. Okay, they're given, okay, this is a pinion gear and this is a gear. Okay, diameter pitch, remember, you know P is N over D. Right? This is a pinion N over D. Number of teeth over diameter of pitch, diameter of your gear. Okay, it's the same. Diameter pitch 10, the gear also must be 10. Pinion 10, P for B, gear also 10. Okay, then the number of teeth of pinion is given, 18 teeth. And of course, we know the number of teeth of the bigger gear. Shouldn't be a problem, okay? All right, okay, then it said that output, because since we know the output speed, then we know our teeth of the bigger gear. Okay, it will drive, okay, this system will drive conveyor drive. Okay, this shaft B, okay, the shaft A is connected to the motor. Shaft B will drive conveyor belt. So with shaft conveyor drive, conveyor belt in the industry. Okay, involved. Kalau conveyor belt actually guys, it's not actually not smooth or conveyor belt because they are carrying material handling, right? They because the shaft attached to a conveyor. A roller will be mounting on the shaft. So this is your driven shaft. So it drive the conveyor. So conveyor belt normally they are carrying load, they're carrying material industry for conveying material, material handling. So they have involved moderate shock, involve moderate shock, torsional loading, and the RPM of this shaft B is 860. So we can know our entry lah, that shouldn't be okay. Now the both of the gear is 20 degree, the pressure angle. Remember the phi is your pressure angle, 20 degree. Remember when you calculate your bending strength, you need to find your J, right? Your spur gear geometry factor, you must follow on the graph phi 20 degree because we have two graph for your J. 20 and 25, be careful, it's given that the phi is 20 degrees. So it means both, this set of gear is phi is 20 degree full depth teeth. Full depth teeth, okay, the material is, okay, they give the material of this gear is this is hardness, guys. BHN mean hardness, 330, steel 330, okay. When you have a set of gear, you can have different materials. Sometimes your opinion is steel, but your super gear, but you are carrying the same diameter pitch. It means the size of your tooth is the same. But the only difference, your opinion and your gear can have different materials. Sometimes the gear, maybe the bottom gear is not steel. It could be cast iron. It could be, sometimes it happens like that. Your opinion is different steel, and this one different material. If you look, the gear here, they have different hardness. So it means different material. This one hardness 330 and this one is less. Dia punya hardness strength is less. The value of hardness is less. So this is a different material. Okay, manufacture of pinion and gear correspond to curve D. Okay, we said that manufacture of pinion and gear, but this is about our, just now, for us to need, remember we need to find our velocity factor, depends on the type of manufacture of the gear tooth, how they form the gear tooth. Okay, they said it will respond to curve D. Curve D, we know what is curve D, we know what is the formula of set the KV for us to find KV. So it's stated like that. Okay. Okay, and so say that, okay, show pair of spaghetti is, okay, phase width is given. So it means, remember to calculate our sigma, we have B, right? Sigma FTP BJ, the B, that's a phase width. It means the thickness of this teeth is 1.25 inch. So it's stated, but this one, okay, this one is just play a trick. Actually, find the safety factor. You know, safety factor is your SN over your sigma bending. But this one, estimate the maximum horsepower. So why this is play around? Because your calculation of your bending stress and your calculation of your endurance limit, yeah, you know, endurance limit, SN, no, you don't have variable, but only your bending stress will be in variable FT. Remember, you understand what I'm talking about? So it means that your bending stress will be in terms of variable FT because we will not, we can find FT since they said estimate the maximum horsepower. So we assume that the safety factor is 1, the border. Maximum, it means border to failure lah, border to pass. It means safety factor is 1. Okay, Clark, if you look on my live video ni. So it means that, Clark, tengok sini. Can you see my live video, Clark? Clark, boleh nampak video saya, okay? Okay, now typically we find safety factor, not by this one. Remember, your sigma B, your calculation, you know FT times diameter P. Can you see my video? Is clear or not? Oh, you can see my video. Hold on. Macam mana ni? You cannot see my video?
Saya okey je, Doktor. Oh,
What about the others? Can you see my video? Muhammad, you cannot see my video, why? Okay. Okay. Please, remember, okay, typically, sample, we need to find safety factor, right? For your project, you find safety factor as long as 1.5 and above is good, okay? But not too much. And for your project, do not make your gears. If you give me the so I've done analysis on gears, safety factor is 10 point something. Some students previously do it like that. Too much, too high, wasting. Okay. But 1.5, 1.6 is good for you. Because gear we already consider KR, KV, KO, already put the factor here. So not too high, but 1.5, 1.6 is good. All right. Okay, in this sample problem, your bending stress is FT times diametrical pitch B, J, KV, KO, KM. So the only thing that you can do in terms of is FT. You will get some value and FT. Okay, your bending stress is in terms of variable FT. Okay, your SN, you know SN is CL, CG, surface vector, KR, KT, KMS, and you times the SN prime. All of this times SN prime. Okay. This one you will get this one in because this English unit will be in KSI lah. KSI is 1000 PSI. So you know. So it means that let's say power. What is the maximum power? So it means okay. You know because we know safety factor. So maximum power it means the border. So safety factor is 1. So it means safety factor is 1. Is your SN in term of FT? Cannot see. Alright, yang lain okay boleh nampak What about the others? You can see my video?
Yes, can see.
Yang lain tu kalau depend sambung record boleh tak? Don't depend on Abdullah. Abdullah kesian dia banyak dia ni. Maybe dia rejoin. Boleh tak sambung record? Possible yang lain? Class, you will get your FT. Are you there, class? Are you listening or not?
Yes, listening.
So it means safety factor 1 because they need to calculate maximum power. So it means our borderline safety factor is 1. So it means SN over. So it means your SN must be equal to SN equal to sigma bending lah. So from there, because our sigma bending SN already we know in KSI we have the value, but sigma be in term of FT. So we get our FT. When you get your FT, so what is power? Power, remember power is FT times velocity over in English 33,000. Tak class. Plus. Okay. Remember F tangent of your pinion kali time V 30. Kalau gear lain pinion lagi 30,000. So you will got your what is your horse? The samples. Abdullah, are you here? Alright. Okay. Okay. Let's look on the sample problem. Okay, now already given just now. Okay, estimate the maximum horsepower that the gears can transmit continuously only at 1%. Okay, 1% chance of encountering tooth bending failure. So it means this is 99% reliability. Okay, it means our expectancy is 99% because 1% of failure, tooth bending fatigue failure. So our reliability is 99%. So that's why, remember when we, for SN, we have KR, right, reliability factor, so 99%, so 0.1814. Okay, so first we calculate for this case. So we just compare because we need to find the maximum power. So it means safety factor is 1. That's we know safety factor is Sn over sigma b. So safety factor 1, it means your endurance limit equal to your sigma bending. So because we need to take the maximum horsepower, that's the point of this question. Okay, then first we calculate the endurance limit. Endurance is Sn. So we know the Sn. First we calculate endurance. Because endurance straight away you can get it. Your Sn prime times your CL, CG, surface factor, KR, KT, KMS. I need to be fast. Kita 45 yang kelas kan? Okay. Okay, CL, what about load? Bending load, always 1. Bending load, always 1. Bending load is always 1 CL. Okay, CG. CG, why is it 1? Because P is greater than 5. Because it's mentioned that, if CG is greater than 5, CG is 1. Diametral pitch is greater than 5, CG is 1. Is 0.5 is less than 5 inch per inch, less than your diameter level. In this question, Pemprov said that your P is 10. 10 is greater than 5. Is 10 is greater than 5, it means, he said it less. Kalau less than 5 is 0.5. Greater than 5 is 1. So our CG is 1. Alright? CG is 1. CG is 1, then our CS. Okay, CS, okay, we have to value. What is 0.68 and 0.7? Because we have why? The question said the hardness for pinion material is different. For gear material is different. The hardness is 330 PSN. For gear is 290. So surface factor will be different. So surface factor is 0.68 for pinion. Why? Okay, why is it? Why is it? If you look, can you see the textbook class? Can you see the textbook here? Am I sharing?
Yes, can see.
Yeah.
Yes, you're sharing.
We go for chapter 8. Chapter 8. Remember chapter 8, we are fatigue failure. Chapter 8 where we have we can find our CS. Where is it? Graph for CS. Mana graph for CS? Surface factor. Where is it? Page? Ini Q. No, yang CS. Surface factor. Mana dia? CS. Surface factor on chapter 8. Mana dia? Figure 8 point bawah. This one. Class. Figure 8.13. That is surface factor. Okay. The gear is, normally gear is what? Machine ke apa? Pasal, okay. Sekarang ni we have in term apa tak hardness. Because it's mentioned that the gear, the pinion is 330 BSN. 330 BSN. Where is 330? Atas nampak kan you see this one is hardness HB. That's BSN. So 320, 330, it is 20, 360. Ini middle is 340 in the middle, right? 330 somewhere here. Okay, where is it? Until where? Gear apa, guys? Machine or fine ground? Which one? Class. Gear is what?
Machine.
It's a hopping process. Yeah, a machine. It's mentioned. Kalau cakap shape ground, be careful. Okay, okay, manufacture formula gear corresponding to curve D. Curve D, if you look on the, what is curve D? Curve D, kalau you tengok for your, yang this curve, right, in your textbook, curve D ni is a hobbing machine, shaping cutters. Curve D ni, for KV, you use curve D, you use KV, this one for your KV. But to mention to you just now, yang about our surface factor is based on apa tu? Based on what is our surface factor? Because gear hobbing ni is machine, it's machine. So our CS, why is it 0.68? Because it's machine. Okay, kita 330 here until machine. If you go here, this one is 0. Betul tak? This is 0.68. Betul tak, class? Class. Okay, find that is 0.68. Okay. So this is 0.68 for pinion. Because our the gear different material. Gear 290 BHN. So the gear is 290 will be here. 280, 43, 208, this one different, 40, 20, 300 here. 219 is close here. Close here, bring until machine. Hobbing is a machine, 0.69. It could be 0.69. 0.7, they put it 0.7, close to 0.7. So for gear is 0.7 for your CS. Okay, KR is 0.815. Why is KR 0.815? Because from the, from your table tu, chapter 15, okay, table, table for your, so KR is 0.814. KR is table apa? KR is KR is table 15.3, table 15.3. Table 15.3. Where is it? Table this one. Page on your textbook. Okay, 99% kan? Okay, it stated that apa tadi? Ni 1% of encountered tooth pain. So mean 99% reliability. So it will be, so KR is 0.814. So KR is 0.814 lah here, from table 15.3. KR 99%, 0.814. So this one is 0.814. Okay, that will be your, sorry, KR, sorry, tadi CS 0.84 opinion. Sorry, CS is surface factor. Saya ni salah tulis ni. CS, sorry, CS is 0.68 just now, surface factor. 0.7 for gear. This one for pinion. Pasal gear and pinion different material. So your KR is reliability factor because 99%. Kita from table 15.3 tu is 0.814 lah KR. So your KT is temperature factor. So temperature ni kalau if not given guys, always less than 160 degree Fahrenheit. It's not given unless it's greater than 160 degree Fahrenheit. You have to use the equation just now. So this less than 160, so KT is 1. So KT is 1, then we have KMS. KMS, okay, so this is pinion and gear. It's not ideal gear, so it's just one way bending. Remember, KMS for pinion and gear, not ideal. KMS is 1.4. For idler is 1. Okay, because they have two-way bending. Because idler gear, the two, they have positive, they have negative bending. So the mean is 0. So they put the KMS is 1. Okay, so but for one-way bending, like output gear, input gear, because only on the surface of the two have positive bending. Positive bending, say the mean is much greater. So the KMS is 1.4. So KMS is 1.4. So what about your SN prime? SN prime is SN prime ni actually guys, okay, take note guys. Kalau in this equation, this sample problem is not given SUT, what material, they only give hardness. Okay, take note. Plus for gear, for steel material, class, are you there? It's always yes. BHN hardness over your 4. That will be your armor. Armor. Okay? BHN over, take note of this. So SN prime is over 4 because okay, it's stated here SN is okay. Take note, your BHN over 4 is will be your SN prime. That's always the case. SUT is 0.4 is over 4. Take note on this. Your BHN over 4 too will be your SN prime. Okay, but if it is given the
sir,
yeah.
And the KR figure 14.13 and 15.3 same. Okay. Figure 14.13.
Okay, this is how you get your KR, table 15.3.
Table 14.13.
Table 14.
Written as KR.
Table 14, chapter 14. This is table 15, chapter 15. Okay, yang table 14 is what chapter is that? What?
Bearing selection.
That's what, that's a table on bearing. Different reliability. The engine already set for bearing reliability. Different. That's for bearing. Itu for bearing. Ball bearing, roller bearing kan. Different. That will be do not use Chapter 14, that one is for bearing. We are on gears. Gears, we use stable gears. This is the engineer already said it. ACMA, American Gear Manufacturing Association, already said for this is for gear. They already said this table. Use this table, not table 14.
So
Table
that
14
would
already said.
be reliability 98% or 97%.
No. For gears, they already set. The basic engineer already set. Yang 14 is bearing, if I'm not mistaken, it's got bearing. That's
Ya,
about
betul.
bearing.
Betul bearing.
Yeah, that's about bearing. The engineers already set, and the bearing manufacturer already set the table for percent. They already done that in terms of quality lah. Already done. What's the factor of KR? That is different case. Bearing different for different. This one we are go for gears. So KR you use table 15.3. 99% 0.814. Okay. Boleh Okay. So that will be okay. Just now SN prime ni always what? If hardness is given, you divide by 4. That will be your SN prime. Okay, will be SN prime. So you have for gear, since the hardness of the gear is for pinion hardness is 330 divide by 4, so we have 82.5 KSI. This unit in KSI, be careful, KSI time 1000 PSI. SN from prime for gear, because different material guy. So gear and pinion do not have the same value of endurance limit. Be careful about that, because the material is different. So SN prime is different because the inner hardness of the gear is 290. Okay, BHN over 4. It is 290, 290 over 4, so it would be 57.8 KSI. Be careful, yang ni gear. You kena bracket kan soal. This one is pinion. So you need to find both. So okay, we can already calculate the SN for pinion and also gear. Okay, now we calculate the bending stress for pinion and also gear. Because we have two gears, and one set we have two gears, right? So we know the bending stress equal to F tangent times diametrical pitch, B is the phase width, J is per gear geometry factor, times KV, KO, KM. Okay, so we know that, but the only thing, F tangent the only variable we unknown, so we can find it because width equal sigma bending equal to your endurance, because it said the maximum also means your stress factor is 1. So sigma bending, for sigma bending, so first you calculate the, mana dia punya, sigma bending, yang ini dia explain on what, this is about, ni yang graph about why you get your CS tadi lah. Hardness yang tadi I explain to get the CS. Okay, sigma bending. Okay, if you look also my live video class. So sigma bending for pinion. First you calculate for pinion. For pinion, what you make like this? Pinion. Okay, sigma bending F tangent. Okay, P, what is our P? Diametrical pitch berapa? For pinion. P is berapa? P is 10 kan? Per inch because pinion is N over D per inch. P is 10. So kita punya BJ, B is what? Our B is berapa? B is 1.25 inch. Betul the thickness, they already given the thickness of your ni. The B is face width, not thin. The face width of the gear is 1.25 inch. Okay, B is 1.25 inch. So J pinion. Okay, so because we have the denominator J, right? For pinion J. What is J? Okay, be careful about J. J ni, if you look on table, to get J is here. So J, okay, D is J. D is value of spur gear geometry factor. Per gear geometry factor. So what is the number of teeth of pinion? Pinion number of teeth berapa guys? Come on, cakapkan saya bercakap ni. Kelas. Pinion number of teeth berapa dia cakap? Number of teeth pinion berapa? 18. Okay. Class, are you there? Hello, class?
Yeah,
okay. Number of teeth of pinion is 18. Okay. Phi is berapa cakap? Pressure angle is 20 degree. Both 20 degree. So you do not use bottom graph guys from your textbook ni. Okay, you punya figure 50.23. Use the upper one. This one is 20 degree pressure angle. Full depth is 20 degree. So use the upper graph. So pinion 18. Where is 18? 17, 18, 17, 18, 19. So 18 is here. So sometimes students will ask, apa sir? You want to use the bottom line or the upper line? So kita use, kalau normally, kalau it's stated, is normally we use load applied at tip of tooth, no sharing, no sharing, no sharing of tooth. So this one no sharing lah, no sharing. Did mention apa tu, full depth teeth still 330 pn, full depth teeth yang 200 degrees full depth tu. So normally we go for no sharing, no sharing. We go for no sharing. So we 18 intersect with this line. So we get here lah berapa value ni, 0.2, 0.21, 0.23. So the 0.23 J is for opinion. Ni. Nampak guys, 0.235. Lebih kurang lah. 0.23. Plus, are you there? Boleh So J is, for opinion J is 0.235. Actually you get from this graph lah. 18 here, 0.235. Why? Macam mana dia so precise 235? I'm not sure. 0.21, 22, 23 lah. Me, I just put 0.23. I'm not sure why you got really 0.235. Actually 0.23 lah. Okay, class clear or not? Class, are you there? Alright, J. So, okay, we got our P. We got our B is 145. J is 0.235. Sebagai this is for opinion. The only thing the FT2 we can find later. KV. What? Okay, dynamic factor. Dynamic factor. What is stated that? Dynamic factor. This one is stated that use curve, I mentioned, use curve D. The way they process the manufacture the tooth by use curve D. Okay, curve D, if you look curve D mana? Okay, curve D, apa dia curve D? Okay, curve D mana? Curve D, this one. This one, curve D. Kalau curve D ni hop shaping, so curve D use, ni lah. Use this one, D. Clear guys? KV 1200 plus V plus over 1200. So they use, okay, KV equal to, if you look my live video, equal to 1200 plus V. Now we have V, 1200. So what is V? So this pinion, can remember guys, pinion, V is what? Your pinion punya pitch line velocity. Remember the equation V is for English unit, pi dn over 12. Tahu kan equation ni kelas? Betul kan? Ini you punya spur gear part 1 punya slide ada V pi dn over 12. That's your pitch line velocity of your gear. So you just put to get the V first, then you put into this question. Because this one we use curve D. This is curve D. So calculate your V. So V you can calculate. Pasal what is diameter of the pinion? So what is the diameter of the pinion? First we need to calculate. What is the diameter of pinion? It's not given there, but we can calculate. Because we know diameter of pitch is N over D. To get the diameter of your pinion is you punya N pinion over diameter pitch. So N pinion we already know is 18. Diameter pitch is 10 plus. So diameter of pinion is 1.8 inch plus. Okay, faham Hello class? Clear or not? Okay, so your V, you calculate your V. V is pi times D. D is in inch. Because this one V, actually V in feet per minute. But this one if you look back your part 1 on gear punya slide, lecture note, pi dn over 12. But this D you starting in value in inch. Times 1.8. Okay, what is the N pinion? Speed of pinion berapa? 1720 already given. So time 1720 RPM over 12. So this one your V will be in feet per minute. So you got your V is ni pi d pinion, pi dn. Pi times 1.8, 17 over 12. So you got 811 feet per minute. So this will be your V. So your V will be put into the equation. So your V will be put into the equation yang D tadi to get your KV. So your KV equal to 1200 plus your V2 811 feet per minute over 1200. So you got your KV is 1.68. Okay, that will be your KV. Okay, that will be your KV. Okay, now we know our KV lah. KV we know. What about KO? KO is overload factor. KO is overload factor. Overload factor you get from the ni, here, table 51. Okay, table 51. Okay, it stated that in the question, the system ni, this system, apa dia cakap? Okay, drive is electric motor. Okay, drive electric motor is, normally electric motor is uniform. If you look to get your KO, you punya source of power, uniform lah. Uniform But the driven involve moderate shock. Driven moderate shock. So berapa kita punya kV ni kelas? Okay, source of power electric motor is uniform. Yes, KO is 1.25 1.25. So your KO is must be 1. Yeah, nampak saya? KO is 1.25. Okay. Okay, KV for opinion. Okay, KV for opinion different guys. Remember, because sorry. KV is the same for both. Sorry guys, KV is the same. I mean about J is different. KV is the same for opinion. Okay, KO is 1.25. KM is the mounting factor. Mounting factor is table 15.2. Mounting factor is this one. Okay, which one that we will use? Okay, sekarang our phase width is said that phase width is 1.25 inch. Phase width is 1.25. So we will use this first column lah. 1.25 is our phase width. So which one? Accurate mounting ke, less rigid, or accuracy? It is the most most not accurate. Accuracy mounting said that less than full face contact. The top one is accurate. Does it stated anything about the mounting here in the question? It said that okay, continuous encountering it doesn't say any most power transmit about the mounting. Okay, it is not stated anything about the mounting. Normally we will use KM is, why we use KM 1.6? Because phase width, biasanya normally this one for accurate gun, normally we go for second one. Less rigid mounting. Less rigid mounting, just to drive a system. And this one for precise. Kalau not stated, okay, our phase width is 1.25, so we go for 1.6. And why 1.6? Because we assume that the general case that I didn't mention anything about less rigid mounting, less accurate contact across. This is a typical macam like your project, like I said, you use this one and the second one. But this one depend on your phase. That is why you use 1.6. Okay, class ada mention just to check sure. Okay, tak ada. Okay, kalau if normally the case we use this one. Okay, use the characteristic ni, you use the middle one. Unless stated that you want accurate yang fully and precision gear lah, your alignment is really precise one. So the one you use the first one. Tapi typically the case we use the second one, and it also depend on our phase width. So 1.6 is the our KM. Okay, KM is KM is 1.6. So our KM is 1.6. KM is 1.6. So we put into the value. So our sigma bending is F tangent is the variable, diametrical pitch is 10, okay, over our B is 1.25, and our J just now is for pinion, pinion must be, pinion J is 0.235, okay, BJ, okay, this is 10 inch, you just put the value, and our KV is 1.68, our KV overload factor je na, berapa overload, KO is 1.25 I tak mention sini. KO just now is, KO overload factor is 1.25. Mounting factor is 1.6. Okay, 1.25 times 1.6. So we got our sigma B in terms of F tangent will be for pinion. Nampak tak yang bawah ni? Sigma pinion is 114 F tangent. This one you need in KSI ya, tapi the variable is FT. Okay, but okay, this one for bending stress for berapa sekarang 4 sikit lagi. Okay, for gear the only different, we have the J is different for gear. Just now for pinion, this one is for pinion. This one for pinion, but for gear, why the value of sigma bending is different? Because J is different. Remember our J, okay. For gear, because our equation same, sigma bending, F tangent, diametrical pitch is the same, B is the same, but the J gear ni, J gear different. KV, KO, KM, everything is the same. But the only thing the J is different. Okay, what about J gear ni? J gear ni berapa? Class. Okay, phi is 20 degree. Phi is 20 degree. So what is the value of our J gear? Okay, class tengok sini. Are you looking in the textbook, class? Are you listening or not? Class. Hello, class. Are you there?
Yes, can see textbook.
Right. Okay, you use the same value, the figure graph ni, figure 15.23 for phi 20 degree. Okay, for J, okay, the problem we don't know the number of teeth because this number of teeth, this pinion just now is 18. So what is the number of teeth of the gear? Gear punya number of teeth berapa? What is the number of teeth of a gear? Of course we know. Ni 1720 RPM, 18 teeth, the gear 860 RPM, we can get the teeth. Apa teeth? Macam dapat the teeth of the and gear punya number of teeth. Plus berapa? Number of teeth berapa yang tu for gear? Class basic question.
18
Huh?
Yang
No,
18
pinion is
bukan?
18. The gear is bigger. The speed of the pinion 170 RPM. The speed of the gear 860 RPM. So the gear must be bigger gear. Number of teeth is much greater than gear. So end gear berapa? Kamu mana takkan ni tak tahu juga. Kelak, basic equation macam mana? N last equal to E N first, right? So what is your E? E is drive over ni, kelas. Ni simple, sepatutnya macam ni lah. This is the basic equation. E is what? Drive over driven, number of two, right? Drive is N2. Okay, let's say pinion is N2, N3 is gear, Drive driven is N3. So this will be your E, kan? C will be your E, N2 over N3. So mean N last, we know that, okay, N last is 860 RPM equal to E is your N2 over N3. This will be your N first. N first is 172 RPM. So N2 ni is 18, kan? So what will be your ni? N3 is N3 is 18 times 1720 over 860. Berapa tu? Cepat sikit.
15. Sekejap. 36.
36. Ini sepatut must know guys ni gear mesti gear is 36 So gear is 36. Dia tak show sini tapi suppose you ni nampak gear dia already calculate sini guys. Tahu kerana ini you must know this thing guys. This is basic. Gear is 36 Entry is 36. Apa tu? Okay, 36 you go for gear 36. Okay, gear 36. This is 30. This is 35. Close to 35. Close to 35, 36 here. At this point, D will be 0.255. 0. Apa? Ini 0.25. Ini tengah ni jadi apa? Kalau 0.25 tengah is 0.227. 0.275 kan? So you punya J for year 0.28 lah. Correct? 0.28, close to 0.28 this one. This one close to 0.28 Class clear ni. Hello class. We always use ini Kalau unless cakap ini yang load sharing, you be careful guys. Kalau cakap if not stated, always no load sharing. Kita look. Unless stated that load sharing, load apply, contact sharing. Nampak in bracket sharing. You use the upper this one. Okay, most of the case we use the bottom one. Okay, so your punya from 36, the number of teeth is 0.28 if your J. Okay, J is 0.28. So we just put into the equation. So the only difference is J lah. So everything is for your sigma bending is the same. Is your FT is the variable, P is the 10, KP is 10, and you punya B is 1.25. J, be careful J. Just now pinion J 0.235. Now is 0.28. Sorry, 0.28 for your J because number of teeth is 36. So your KV everything is semua the same. Your KV KV just now is 1.68. Your KO is 1.25 and your mounting factor is 1.6. Okay, 1.6. Everything is the only difference is your J. So your sigma bending for gear is you got it 96 F tangent because the only thing F tangent is a variable. Okay, class? Class, sikit lagi Hold on, sikit lagi. Okay, sekarang kita have to 4 pinion. Okay, it means 4 pinion sigma bending is 114 F tangent. For gear, sigma bending is 96 F tangent. Because, okay, kalau F tangent is no, find safety factor, of course, straightforward, find safety factor, SN already calculate. But the question is asked, maximum horsepower. We know, okay, maximum horsepower, it means that, okay, you maximum, it means that our borderline of SN over sigma B is the same lah. So because it means the border, it means maximum horsepower you could carry. So it means that our safety factor is 1 lah. So you punya SN over sigma bending. Okay, we have both for gear and also because sigma bending for gear and also for pinion. First for pinion. Okay, we know that our SN just now, SN already calculated. Okay, just now SN already calculated as SN for, just now SN for gear pinion lain. SN for pinion, SN is, just now we calculate is 63.9. Okay, KSI. For pinion, and the sigma bending for pinion is 114 FT. So since safety factor is 1, so we can get, since safety factor is 1, so we got, so endurance limit equal to our bending stress lah. So from here we get FT for pinion is FT for pinion is 561 pound force. Okay, this one will be pound force. This one FT for pinion. For gear just now, okay, SN for gear, SN gear just now is already calculated SN for gear because gear different material, remember? So our SN prime 2 will be different, SN prime 2 will be different. So SN for gear is 57.8 KSI. KSI is times 1000 PSI, So yang ini so sigma bending for gear is 96 F tangent. The only F tangent is variable. So from here we equal. I mean bending equal to endurance limit. That's a maximum. So we can get the FT is from here F tangent for gear is 602. 602 pound force. Okay, it means that the system macam ni. Okay, if I make the system, okay, this is your pinion, this is your gear. The system, okay, bawa gear tu to drive conveyor belt, okay, so ini okay, let's say the system running lagi, ini 1720 RPM, ini 86 RPM, so this one will be 860 RPM. So F tangent, okay, if you look the free body diagram of the pinion, okay, drive like that, so this will be the M tangent. F tangent to the pinion. The F tangent that we calculate for the pinion is 561. So need 561 pound force. So we know what is the power. Pinion, what is power, guys? Power punya equation berapa? Power is what? We know from equation, we have equation for power, right? Okay, we know what is power. Power is the rate of work or H. Power is, remember your previous equation from your gear part 1, power is F tangent for English unit over 33,000. So you got a power in horsepower. So for pinion, we know this is 561 pound force. Okay, pound force times velocity of the pinion. Just now we calculate and the pitch velocity. Remember pitch velocity we calculate just now to get our kV. Our pitch velocity just now we get is kV is 811. V is the same. Pitch velocity for gear and pinion is the same. Besar the tangential velocity. Guys, are you with me or not, class? So FT we already know. Velocity is 811. 811. Feet, everything the unit is there. Pound force, this one 811 feet per minute. Okay, over 33,000. So we got for pinion the power is from the pinion Okay, why did they choose the pinion? Why? Because they cakap the maximum the gear. Kenapa? Why they don't take the? We have two cases, right? FT for gear is 602 pound. FT for 561 is for pinion is 5. Why do they take the minimum? Why don't they take the this one greater? Kenapa? I just want to ask you guys. Kenapa they take the minimum F tangent that we can get? For pinion, the F tangent different. If we in the case kita cakap F tangent that it could produce 561 for gear. Actually, when you calculate F tangent is different. Do not confuse. This one they want to estimate the power based on the is given the system. We calculate the bending stress. We calculate the endurance limit. So even for the gear cases, the maximum FT is 602. For pinion case, you might ask me, so why F tangent is different? No, this is the case we need to calculate the cases based of bending and endurance because the teeth on the gear different material and the J is also different. On the pinion, the material is different. Also, the J is different. Sebagai geometry for pinion, because number of teeth is smaller than the gear. Gear 36 number of teeth. So, you mean the bending stress will be different based on the tooth acting on the pinion, and also the bending stress on the gear will be slightly different because gear different material and also the J is different. Number of teeth is different, 36. So that's why the F tangent is different. Okay, from here, why do we choose the minimum, not 602? Nanti question ask like this, so you take yang gear cases, so you'll be wrong. So why you say maximum was because this the only, the point is why they take this one. This is the only power because we based on the opinion. We based on the opinion. Because kenapa kelas? Kenapa opinion? Kenapa tak ni? Hello class. Do you understand what I'm talking about? Why not here? Because kenapa? Because the pinion yang connected to the motor, betul tak kelas? Hello kelas.
Betul.
Motor tu from pinion kan. First motor connected to the pinion, then we have F tangent on pinion, betul tak kelas? Okay, we have tangent on the pinion. The F pinion that we choose, not the gear. Okay, so F pinion tu, okay, we got the F pinion. Apa tu, the F pinion tu just now we from here apa? F tangent pinion is 561 kan? Okay, F tangent pinion is 561 pound force. So what is the power? Power rate of work, H lah, equal to F tangent times V 33,000. So you put the value the pinion here. 561,811 V. So you got, so the maximum that the motor can carry 13.8 horsepower. Do not take gears pasal dia cakap because power from pinion. Itu yang explain. Okay, tapi typically your analysis for your project, you go for find the safety factor. I hope you understand what I mean. N equal to Sn over sigma. You have two safety factor, guys. Safety factor for pinion and safety factor for the gear, because the value of bending stress on the pinion and bending stress on the gear will be different. Also, the endurance limit on the bending stress, endurance limit of the pinion different, endurance limit for the gears is different. Kita tengok endurance limit is different. Nampak, for gear lain, pinion different. Okay, normally case you get the safety factor lah. Tapi sometimes question like this, okay, just your variable is just F tangent. Alright, okay, kita end up. Okay, ada apa-apa question before kita quit? Sorry taking your time, dah pukul 5 lebih, so we go for attendance. Test 2 cover sampai this, nanti second meeting is about surface stress. Our second meeting I will explain to you about surface stress. The one will be, okay, test 2 cover until gear saja. That's all for your test 2. And test 2, if I'm not mistaken, 30 of June. 30 Jun. Test 2. Test 2 will cover bearing, bevel, and gear. Gear, we have another one more topic, surface stress. Surface stress is much simpler, just straightforward. Ini session berapa? 23 kan? Component design. 23. Okay, kelas scan your attendance. Assalamualaikum warahmatullahi
Tak share screen.
Oh, sorry. Tak share screen. Okay, scan your attendance. Assalamualaikum warahmatullahi